All right, here we go. Okay, so today we're going to start on Chapter 2, and this is going to be a look at the research methods that we're going to be using throughout this semester. Now, today we're going to be focusing specifically on basic terms and definitions. So in your reading for today's class and in your future readings, you're going to notice that there are a lot of terms that the psychology of learning likes to use, and some of them have very specific definitions that differ from the way that we normally use them in everyday English. So we're going to make sure that we go through the important ones here so that moving forward, when you're doing your reading, we understand what is going on and what everything is all about. And then once we have those basic terms and definitions, for next class, we're going to revisit the experiment on learned helplessness and apply those terms and definitions to analyze more deeply that interesting experiment. All right, so we're going to start off our basic terms and definitions with the idea of an independent and a dependent variable. So before we define independent and dependent, we have to define what we mean by a variable. So a variable in the psychology of learning is going to refer to any characteristic of whatever it is that you're studying. If it's a person, if it's a place, it's a thing, any characteristic that can change, that is vary, hence the variable, it can change over time or from one situation to another. Basically, it can be different in different times. It can be different at some, in different ways. So one variable that is often studied in psychology is the variable of age. So age is a variable because people are not all the same age. You can have people that are teenagers, you can have young adults, you can have elderly individuals, you can have little infants. Age is something, it's a characteristic of a person, but it does change over time, hence it's a variable. In some experiments, oftentimes they will include time as a variable. So for example, in this quiz that you just completed, the duration that you received for this quiz is 10 minutes, but that duration is a variable. It could be 5 minutes. It could be an hour and a half. It could change over time or over situations. So it's variable, hence it would be a variable. So variables are, again, anything that can change due to any characteristic that can change of a person, place, or a thing. So one more example of something that's a variable would be grades on an exam. So grades on an exam, you could get 100%, you could get 67, you could get a wide range of different outcomes. That's a variable, it's a characteristic of that situation. What was your performance? That can vary, that can take on different values. So when we're talking about variables, we're talking about things that can take on different values. And then when we take a look at experiments, typically they split their variables up into two broad categories called the independent and dependent variables. And so we're going to turn to that right now. So an independent variable is a variable that is manipulated in an experiment. So what we mean by this variable that is manipulated in the experiment is it is the variable that the experimenter themselves controls. It's a variable that the experimenter themselves changes. So for example, if I was interested in the effects of time on exam performance, time is the independent variable, and I would manipulate that variable in an experiment. So I would give some students 1 hour to complete their exam. I would give other students 2 hours to complete their exam. I would give other students 20 minutes to complete their exam to see how their performance changed. But importantly, I'm the one that is manipulating that variable. So I would tell this student, it would be unethical to do it in an actual exam. So let's say we're doing a simulation. I would tell this student, you got 20 minutes to do this exam. I would tell this student, you got 1 hour. I would tell this student, you got 2 hours. And I'm the one that is manipulating this variable. So even if this student comes to me and says, hey, can I have 1 hour? I'd like 1 hour. I would say no, because this is the independent variable. Well, I wouldn't say that, but you get the idea. I would say, no, this is the independent variable. I'm manipulating it. You're getting 20 minutes. If this student came up and said, hey, I know I got an hour, but I'm done. I was 20 minutes in and I'm finished. Can I be in the 20-minute group? I would say no. Go back and sit down and continue your exam, because I'm manipulating that variable. So the independent variable is the one that is manipulated in an experiment. It's the one that the experimenter changes. It's the one the experimenter has control over, the one that they are setting up. That's one way to get an independent variable. Another way to get an independent variable, though, is to vary that variable systematically across different conditions in the experiment. So this is something that opens up things that we cannot control, opens it up to experimentation. So whereas I can control time, and I can say, you get 20 minutes, you get 30 minutes, you get an hour, you get 40 seconds, I can manipulate that, right? I can control that as an experimenter. There's other variables that we could be interested in that we can't control, but we can still use them as independent variables by varying them systematically across the different conditions in an experiment. So what do we mean by that? Well, an example of a variable that can be an independent variable but you can't manipulate is age. So whereas I could tell this student in my duration for the exam experiment, I can say, you get 20 minutes. And then, no, wait, you get an hour, you get 2 hours. I can manipulate time, but I can't tell this individual, I can't ask her, how old are you? 16? Okay, you're 30 for this experiment. Poof, right? I can't do that. But what I can do is I can collect out of all the subjects, everybody that is in this age group, and I will analyze them separately. They'll form their own group. Young adults form their own group. Elderly individuals form their own group. And if I had any little babies in my experiment, they would form their own group. So even though I can't control age, I can't vary it, I can organize it or vary it systematically across different conditions. And I can say, all right, all the teenagers are going to be in group 1. All the young adults, group 2. All the elderly individuals, group 3. All the infants are going to be in group 4. And then I can control those conditions in a particular experiment. So independent variables, these are the ones that either the experimenter themselves controls or the experimenter themselves systematically varies or organizes them in that particular experiment. All right, any questions on independent variables? All right, dependent variables are the other ones that are measured or used in an experiment. And this variable is the one that is actually measured in an experiment. So this is oftentimes a tricky version of the definition for a dependent variable, because while it's absolutely true that a dependent variable is the one that is measured in an experiment, sometimes students get confused because you measure an independent variable. So when I was asking these subjects here, how old are you, so I can place them in different groups, technically I was measuring that variable. That does not make it a dependent variable. What really makes something a dependent variable is that not only is it measured, but it is allowed to vary freely in the experiment, specifically to see if it's changed by the independent variable. So that varies freely aspect is really the key to a dependent variable. Because whereas in this experiment about exam performance across duration, whereas I can say, all right, independent variable is time, because you get 20 minutes, you get 1 hour, you get 2 hours. The dependent variable would be performance. And as an experimenter, I would allow that to vary freely. So maybe this individual will get 100%. Maybe they'll get 50%. Maybe they'll get 70%. I'm going to allow their performance to vary freely. Whatever they decide to do is what I'm going to measure, and that's the dependent variable. So we're measuring it, and we're allowing it to just do what it will. So the experimenter would not change the performance here. You wouldn't go up to him and say, the answer for number 4 is A, number 5 is B. Let's make sure that you get a high score. You just sit back on the dependent variable and you're like, let's just see what happens. We're going to allow it to vary freely to see if it gets changed by the independent variable. Does time affect the performance of these particular individuals? So that's the idea of the independent and dependent variable. So again, remember that independent variable is the one that the experimenter either controls, it's the one that he or she changes, or it's the one that you're organizing your subjects by. The dependent variable is the one that you're measuring, which you just sit back and let it happen, right? You allow it to vary freely. And what you're looking for is you're looking to see if your manipulation of the independent variable causes changes in that dependent variable. And that brings us to our next idea of a functional relationship. So functional relationships, this is a good example of one of the first terms that will not mean in everyday language what it means for psychology of learning. Because when I hear functional relationship, I think of two people that are getting along rather well and making each other's lives better. So it's like, oh yeah, you know, I started dating Dave and we have a very functional relationship. Oh, you guys over there, you got a dysfunctional relationship. That's not what this means. This is not about matchups. Functional relationships is about the relationship between when an independent variable changes, what happens to the dependent variable. So that relationship changes in the independent variable, what happens to changes, how does it change the dependent variable? That's what that functional relationship is all about. So if I was taking a look at the effect of performance, changes to the dependent variable, changes to performance, what is the relationship between changes to the independent variable, duration of the experiment, on changes in the dependent variable, I might find that people who have a very short time to do their exams perform very poorly. However, as that variable changes and people get increased durations to complete their exams, they perform better. But there's an upper limit because people who get 2 hours, they go over their exam, they start to second guess themselves, they change correct answers to incorrect answers, and your performance actually goes down. So it could be that there's a functional relationship between time, the independent variable, and exam performance, the dependent variable, where low time leads to poor performance, middle time leads to high performance, extremely long times leads, again, to low performance. So again, that functional relationship, that's a lot of what we're going to be learning in this semester. What is the functional relationship between different variables? How does changing the rewards that you offer an individual change the amount of behavior that they do? How does taking those rewards away change the behavior that they do? How do the characteristics of a model who's modeling a behavior change whether or not that behavior is imitated? All of those functional relationships is what we're going to be looking at. So again, you can take a look at the functional relationship between duration, the independent variable, and performance, in this case, the dependent variable. And again, those functional relationships are what we're going to be looking for. So if you were looking at age, and you were looking at things like cognitive abilities, your cognitive abilities when you're a baby are extremely low, right? So cognitive abilities is the dependent variable. Age is now the independent variable. Cognitive abilities low when you're an infant. You really can't do much except cry, eat, suck, and poop. I think those are the 4 things that all babies can do. However, your cognitive abilities increase as you're a teenager. They increase as you're a young adult. They peak at some point, and then they start to decline. Many of them start to decline in your elderly years. And again, that's a functional relationship between age. How does age change your cognitive abilities, your dependent variable? Incidentally, it's not all doom and gloom when you get older. A lot of your cognitive abilities, or a subset of them, actually get better as you get older. But these again are the relationships that we're looking at. What gets better, what gets worse as age increases. All right, so again, we have this idea of a functional relationship, and it really can be between almost anything that you want to study. So what's a functional relationship between the amount of time that that you have for an exam and your performance? What's a functional relationship between hours of studying and your performance on an exam? What's a functional relationship between test anxiety and performance on an exam? All of these sort of independent variables that could affect exam performance. You might be interested in those functional relationships. And people have been studying the functional relationships of age. Just tons of work has been done on that, especially now that we have a large aging population. And also we have an extremely large young population. Now, the effects of aging, the effects of that developmental change as you age, that independent variable is being linked to a lot of dependent variables, so they're looking again at those functional relationships. All right, so any questions on functional relationships or independent and dependent variables before we go on to the next basic term? All right, next one, we're going to be seeing a lot of stimulus and response. Much of what we're studying is going to be how does a particular stimulus cause or increase a certain response. So we need to know what a stimulus is, and importantly, stimulus has a very wide definition. So stimulus can be any event that can potentially influence behavior. So that is an extremely wide definition. So most people can think of certain, when the word stimulus comes to mind, a lot of people think, oh, maybe like a noise. A noise is a stimulus, or a flashing light is a stimulus, right? So when you're driving to work and you see the red light, you see the green light, you see the amber light, those are events that could influence your behavior. Those are all stimuli. However, a stimulus can be any event that can influence behavior. So importantly, it can be behaviors. So it can be other people's behaviors that then influence your behavior. It can be your own personal behavior that then influences your next behavior. So other people's behaviors, if somebody walks up to you and says, in the hallway and says, hey, how you doing? That's a stimulus. It's going to potentially influence your behavior. It might influence your behavior to say something like, well, it's not the heat, it's the humidity. And then that behavior that you just did could potentially influence your behavior a few seconds later, where you're walking down the hallway going, why did I say that? I sounded like a moron. So all of these are potential stimuli that can influence your behaviors. The response is a particular instance of a behavior. So a response in psychology of learning is a particular instance of a behavior that's been identified. So we need to have this clear, because while an individual or an animal or a subject can have many different responses, typically we're looking for one type of behavior. So that's the one that's typically going to be measured, and that's the one that we're going to be referring to for response. All right, so we have responses, a particular instance of behavior, stimulus, any event that can potentially influence behavior, which brings us to this two types of behavior that we might consider: overt and covert behavior. So overt behavior, we'll start off with a straightforward one. This is a behavior that has the potential for being directly observed by an individual other than the one that is performing the action. So that potential for being directly observed is important, because it doesn't have to be actually directly observed to be an overt behavior. It just has to be potentially observed. So if you watch a lot of spy movies and they're like, we're going on a covert operation, right? We're going to do this covert mission. That covert mission is overt behavior, because you could potentially look at those people and say, hey, they're doing a spy mission. I have observed this behavior. They're doing things that can be observed. Hence, that would be an overt behavior. So it's potentially being directly observed, and importantly, by the individual other than the one performing the action. So this individual over here, She is doing a overt behavior. She is smiling. Smiling has a potential to be observed by somebody else. So she knows that she's smiling because she can observe her own behavior, right? She can introspect in her mind and say, am I smiling? Yes, I am smiling. But I can also walk by and I can say, hey, this person is smiling. Hence, smiling in this case would be an overt behavior because I'm not the one performing the action, but I can observe it. On the other hand, a covert behavior, that can only be perceived by the person that is performing the behavior. So that is the big distinction there. It can be perceived only by the person performing the behavior. So while she is doing the overt behavior of smiling, inside her mind, she might be feeling horrible. She might be feeling dead inside. It might be the worst day of her life, but she's like, no, I'm going to put on a brave face. I'm going to smile. Nobody's going to know the pain inside. Well, those emotions inside, the pain inside, the negative thoughts that she's having, those are all covert behavior because she's the only one that can observe those. The overt behavior is the smile. That's what we can observe. And sometimes your inner feelings will spill out into overt behavior, but it's important to differentiate between the two. So she might have those negative thoughts, and eventually she might stop smiling and she might start crying. And we can observe the crying, but we can never observe the negative thoughts. She might tell us, oh, I have a lot of negative thoughts, and here they are. I'm going to verbally describe to you what those are. And that verbal description is an overt behavior because we can listen to it, we can observe it. But again, we can't look into her mind and say, yes, I can see your thoughts. So thoughts, inner emotions, those are all covert behaviors because they cannot be perceived by anyone other than the person performing the behavior. So this is a very important distinction to keep in mind because as we saw last time when we were looking at that 60 Minutes report on gambling, there's a lot of behaviors that are done in secret. So this woman embezzled $250,000 from her employer in secret. However, that embezzling, that sneaking off to the casino, that's all overt behavior because it has the potential to be observed. And in effect, at the end, it really was observed because she got arrested. So somebody observed the behavior. But again, covert doesn't mean done in secret. It just means whether or not, the distinction is whether or not the behavior could be observed. So remember that when you're reading overt behavior, doesn't need to be observed, but has the potential to be observed. It's something that can be seen or can be heard or can be detected. Covert behavior is inner behavior that only the person doing it can actually observe. All right, so that was covert and overt behavior. We are now going to take a look at appetitive and aversive stimuli. And this is the one that probably has the biggest difference between the way that psychology of learning researchers use it versus people in their everyday language. So appetitive usually is meant something that's tasty, something that you like. However, in the psychology of learning, an appetitive stimulus is any event. So remember that a stimulus is an event. Any event that an organism will seek out. So anything that an organism will try to get close to, will try to approach, will look for, will search for, those are all classified as appetitive stimuli. And an aversive stimulus is any event that an organism will avoid. So any event that an organism will try to get away from, any event that an organism will try to shield themselves from, anything that organism will avoid. And that is it. That is the sum of the definition. And what you need to do when you're learning the psychology of learning is to not project any other definitions on this. So first off, we'll notice that the same stimulus can be appetitive for some subjects and aversive for others, right? So I've talked to a lot of students in my days, and some students are absolutely terrified of exams. They'll do anything that they can to avoid it. They're the ones that ask, well, can we get an exemption for that, for that final exam? Is there any way that, if I miss the exam, maybe I don't need to take it? For them, exams are an aversive stimulus because they will try to avoid that exam as much as possible. I remember I was reading a tweet from a teacher who said that she started requiring attendance. She started requiring, no, not attendance. She started requiring documentation for people that miss exams because the semester where she didn't require documentation, 5 people's grandparents died. And the one where she did require documentation, nobody's grandparents died. So she decided that documentation was saving lives and it was important enough to be included. But really what we have here is we have students trying to avoid that exam and doing anything to do it. For them, an aversive stimulus. I've known other students who are who want to take that exam, right? So they're like, you know what, I've been studying, I know this inside and out, give me that exam. I want to show what I know. This is my time to shine. Yay, exam, right? Maybe not that not that extreme. But for them, an exam is something like, yes, let's do this. It's an appetitive stimulus. It's something that the organism will actually seek out. And if you go into a class and you're like, hey, there's no exams in this class, some students will be like, oh man, really? Like, okay, fine, whatever. It's an appetitive stimulus for some. So things that are appetitive for some will be aversive for others. We'll see this in an actual clinical treatment of an individual. We'll watch this video later on in this class to illustrate a lot of our principles. But just to set it up, this is Harry. It's shot through a one-way mirror, that's why it's a little bit blurry. But he is a self-injurious individual. So he will literally hit himself, bite himself. He's broken his own nose many times. It's a behavior that needed to be trained out of him. And we'll see how psychologists were able to treat him. But one of the interesting things about his case was that he actually sought out restraints. So they had restraints for his arm. They would put him in these either metal or plastic restraints. They would strap him to his arms so that he couldn't actually injure himself with his arms. And he wanted to be in these restraints. If he was out of the restraints, he would try to get the restraints. He would try to get people to put the restraints on. He seeked out those restraints, even a straitjacket. He liked, I don't want to use the word like, that's not right. He seeked out these restraints. He wanted to be put into these restraints. These restraints for him are an appetitive stimulus. For most of us, it would be an aversive stimulus. So if somebody came to you and said, hey, do you want me to bind your arm so you can't move? You would say, no. And you would actually probably do that move. You would back up and you would say, I would like to avoid that. So again, these different stimuli are aversive or appetitive based on the individual. Appetitive, they will seek it out. Aversive, they'll try to avoid it. And one of the traps that often students will fall into, and I momentarily fell into that trap, is do not think that an appetitive stimulus is something that a person likes and an aversive stimulus is something that they don't like, because that is not part of the definition. And a nice example of that we've seen before are people with an addiction. So when they were talking to this woman here, when they were also talking to the other one, they had nothing but horrible things to say about the slot machines. They knew that these slot machines were horrible. They did not like these slot machines. When they were asked about it, they were like, oh, these things steal your soul. They steal your humanity. But those slot machines were an appetitive stimulus for them because they would seek them out. So you might not like something, and this is also something that occurs in abusive relationships. You might know that the person with you that you're with is horrible. You might not actually even like them, but as long as you seek them out, they are, for the psychology of learning, an appetitive stimulus. And also, aversive stimuli are things that, people avoid. They might like them. So if you are trying to clean up your eating habits, junk food is an aversive stimulus. Even if you love ice cream, you might say, no, I'm trying to avoid this. It is now an aversive stimulus. So again, don't fall into the trap of, oh, appetitive is what they like, aversive is what they don't. Appetitive is nothing more than a stimulus that an organism will seek out. Aversive is nothing more than a stimulus that an organism will try to avoid. All right, next term, establishing operation. So an establishing operation is a procedure that affects the appetitiveness or the aversiveness of a stimulus. So for example, for the stimulus of an exam, studying is an establishing operation because that'll affect the appetitiveness or aversiveness of a stimulus. So if you don't study at all, you're going to change that exam into a very aversive stimulus. You're going to want to avoid it, right? However, if you study a lot, if you invest in a tutor, if you spend hours and hours, gave up weekends in order to prepare for that exam now becomes an appetitive stimulus, something that you're going to seek out, something that you're going to say, I put in all this time, where's my exam? So that can change, and the way that it changes is called the establishing operation. When we take a look at Harry and his treatment, part of what the clinical psychologist's challenge was to find out what were the establishing operations that caused these restraints to be so appetitive for Harry. What was it about his past? How was he reinforced? What were the rewards he received that made these restraints actually something that Harry would seek out? So what were those establishing operations? One very common establishing operation in animal research is to make sure that your animals are deprived of as much food as they want. So an establishing operation is to reduce the amount of food that you give to an animal in an experiment in order that it will seek out so that that food will become appetitive. So typically what we do in an experiment is we'll take an animal and for about 2 weeks, we'll feed it as much food as it wants. And that establishes what's known as its ad lib weight. So we take its ad lib weight, and then what we do to motivate it for these establishing operations is over a period of a couple of weeks, we'll decrease its food intake until it drops to about 80% of its ad lib weight. So if it used to weigh 10 pounds, that's a huge experimental subject, but if it used to weigh 10 pounds, we'll reduce its weight until it's about 8 pounds, 80% of its ad lib weight. Just so you know that we're going to be reading a lot about animal research, and just so you know that typically in these days, animals are treated very ethically, especially in psychology research. Does anybody know when an animal in the wild, what percentage of its ad lib body weight it typically is in the wild? 70%. So even when we make them hungry in the lab, they're still 10% heavier, 10% healthier than they would be if they were out in the wild. But that's another example of an establishing operation. So an establishing operation that, let's talk about the aversiveness of a stimulus. Everybody's probably gone through this one. If you have ever been hungry for Thanksgiving dinner and you just can't wait and you're like, man, I want that turkey, man, I want that gravy, ooh, I can't wait for those mashed potatoes. And then 2 hours later after the meal, your relatives are like, hey, would you like more turkey? And you're like, no, take that away. I cannot have it anymore. You have taken an appetitive stimulus and you've turned it into an aversive stimulus through an establishing operation of consuming like 10,000 calories. So again, these are all things that can change whether or not we seek out or avoid a particular stimulus. All right, and again, one of the things that we're going to see are things that affect the appetitiveness, things that affect the aversiveness of a stimulus, and also just know that these things can change in an individual or in different situations. All right, going on, contiguity and contingency. So these are two terms that are going to come up a lot over the next few weeks. So let's take a look at them. Contiguity, that means a closeness or nearness of events. So when two events occur, do they occur close together? Do they occur near? And the two types of contiguity that we're going to be focusing on, the first one is temporal contiguity, and that is when events occur close together in time. So the event of handing in an exam and the event of getting your grade, that does not have high temporal contiguity. That occurs very far away in time, right? Because sometimes you have to wait a week in order for your exam results. So that would be an example of low temporal contiguity, things not occurring close together in time. If you do your GREs and you do them when you do them online, as soon as you hit that submit button, it'll pop up what your score was. That's high temporal contiguity, because as soon as you're done the event and you hit submit, boom, here comes another event, your grade. So that would be high temporal contiguity. And temporal contiguity is one of the really big, important factors that affect learning. So we saw the researcher on gambling addiction talk about how one of the reasons why these slot machines are so incredibly addictive is because, unlike other forms of gambling, your pressing the button is followed very closely in time with your winning that particular bet. So the temporal contiguity is very high for slot machines. You press the button, it spins, boom, it's done, and you get rewarded. On the other hand, things like poker have low temporal contiguity because you place your bet and then you got to wait for the next guy to react to it. Then you got to wait for the next person to react to it. And then you got to wait for the next person. And then there's always that one player who's going to sit there and think about it for 20 minutes before they make their decision. It takes a long time in poker. She also mentioned horse racing. Horse racing also does not have high temporal contiguity because you place your bet at the window and then you got to wait until your race comes. You got to wait for the horses to run all the way around the track. And that's why slot machines are way more addictive. Way more people are addicted to slot machines than to any other form of gambling. Part of that reason is that really high temporal contiguity. You place a bet, you press the button, there's your outcome. You press the button, there's your outcome. Very, very close together in time. So that's temporal contiguity. The other form of contiguity that we're going to focus on is spatial contiguity. And that's when things or events occur close together in space. And that is also a very important factor in learning. You are much more likely to learn things, and you're going to learn them much more quickly if they're temporally contiguous, close together in time. And you're much more likely to learn things, and you'll learn them much more quickly if they occur close together in space as well. So that's another thing that contributed to the addictiveness of slot machines, because you get your payout exactly where you're sitting, right? So you press the button, and you have the little screen that tells you, yes, this is your payout, and they're very close together, right? They're close together on that same machine. And if you want to cash out, it's also right there. It'll print you your ticket right there. You're close together in the machine. Horse racing, not so much, because in horse racing, you're at the track, you're watching the horses go around, you got your ticket, your horse wins. Yay, you're gonna get your money. Where do you have to get it? Well, you got to walk to the window. You got to hand in your ticket. You got to get your money over there. A lot of distance between where you saw the race and then where you pick up your money. Those factors, the fact that they're far apart from each other, means that horse racing is going to be less addictive than slot machines, and slot machines are the ones that have the highest rates of addiction. Again, because slot machines have high spatial contiguity, things occur close in space, and high temporal contiguity, things occur close in time. They've kind of doubled up on their contiguity. So in most cases, high spatial, high temporal contiguity will increase learning. There are some exceptions that we'll come across in this course, but typically, the more spatial contiguity there is, the closer events are in space, and the closer events are in time. The quicker you'll learn, the more powerful you will learn. It'll all contribute to the power of these learning phenomena. All right. Any questions about contiguity before we get to contingency? Make sense? All right. So contingencies are a functional relationship between two events. So we're talking about that functional relationship between two events. But a contingency is a special case of this functional relationship. So it's like a subset of these functional relationships. And it is where the occurrence of one event predicts the probable occurrence of another event. So they have this predicts the probable in this because sometimes one event will definitely cause another event, right? So if you throw a ball away from you, that will definitely cause the event of that ball returning to the ground, right? So some contingencies, some functional relationships, they'll always occur. However, many of the interesting things in learning, because we're dealing with human behavior, and because we're oftentimes dealing with the real world, just has the probable occurrence of another. So one contingency that we're all familiar with, if we drive, you know the rules of the road, you know the rules for a stoplight. You can run a red light and nothing might happen. But if you run a red light, occurrence of one event, that predicts the probable, you're going to get a ticket eventually, occurrence of another event. So it's not going to occur every time. It's not like every time. I mean, you have to be super unlucky if every time you ran a red light, you got pulled over by a police officer. But again, running a red light predicts the probable occurrence that you're going to be pulled over. So that's a contingency when one event, the occurrence of it, predicts a probable occurrence of another. So another example of that was the embezzlement. So embezzlement predicts a probable occurrence of you're going to get arrested. And it didn't happen every single time she embezzled funds. So she embezzled $250,000 over a period of time. But there was a contingency there that says if you embezzle funds, you will get arrested. And that contingency, even if it doesn't happen every single time, the one event predicts the probable occurrence of that other event. All right, so that is contingencies, and that is our final term for the day. Any questions on any of those that we've seen so far? All right, so what we're going to do to wrap up today's class, we're going to revisit the learned helplessness experiment that we saw last time, and I will leave you with a challenge for next class, something for you to think about, to kind of think through on your own, to basically practice a little bit of the use of these terms. So back to Martin Seligman. So he studied the effects of prior learning on subsequent learning. So this is a recap of learned helplessness. So he took dogs, he split them into 3 groups for part 1. Group A received no shock. So group A, these dogs would be in a room, they would be placed there individually. There was a panel on the side of the room that would stop shocks. There was a floor that could deliver an electrical shock. And these dogs, they received no shock, so they just spent time in the room. Group B received escapable shock. So the bottom of their room would be shocked, and it would be turned off if they pressed the panel. And then Group C received inescapable shock. They received just as much shock as Group B, so they were yoked or tied to the amount of shock that these dogs received. However, they could not escape the shock because their panel did nothing. So in this case, Group A never learned anything in this part 1 because there was no panel to press. Group B learned eventually to press that panel to escape the shock. And then Group C, again, nothing to learn. Their panel did nothing. They just experienced that shock. And then what he did was in part 2, he put all of these dogs, again individually, into a shuttle box. And what would happen is a speaker would play a tone. That would be followed by the floor being shocked. And to escape that shock, all the dog had to do was jump over the hurdle to the other side of the room. Then they would hear a tone on the other side, indicating that the floor was about to be shocked, and all they had to do was jump over to the other side of the room. And the question is whether they would learn this response to either avoid, or you can also completely escape the shock in this situation. So how did that prior learning in part 1 affect the dog's abilities to learn that jumping response in part 2? Well, Group A was able to learn the jumping response in part 2. They were able to learn to avoid the shock. Group B, who previously learned how to avoid shock by panel pressing, were also able to learn to avoid shock by jumping over the hurdle. However, Group C, who was unable to avoid the shock in part 1, even though they were able to avoid shock in part 2, they never learned that jumping response. They never learned to avoid the shock. So they did not learn to avoid it in part 2. So as we saw last time, this was a very important study, helped further our understanding of depression, helped identify behaviors that lead to depression, and helped Seligman found positive psychology. So what we're going to do for next class is we're going to analyze this study in terms of the new terms, new definitions that we learned. So you have these in your lecture notes. I encourage you to go through this exercise, write down your answers, and then check with the posted lectures, see if it differs from what you wrote. But what we're going to be asking is, in this experiment, in Martin Seligman's experiment, what are the independent and dependent variables? So for part 1 and part 2, what were the variables that Martin Seligman manipulated? So what were the ones that he changed, he controlled? And then what were the variables that he just sat back and measured? So what were those for part 1, and part 2, the independent and dependent variables? What were the stimuli and the responses? So for part 1, what were the stimuli? There's going to be a bunch, so try to identify the important ones. Stimuli in experiment 1, important stimuli in experiment 2, and what were the responses? So there's a variety of responses as well. So again, identify the ones that are crucial to the experiment, the ones specifically that Seligman was trying to measure the behaviors he was interested in. All right, next, the overt and covert behaviors. So for these ones, there's going to be some overt behaviors that we've already mentioned, right? So try to make a note of those overt behaviors. But then this one is also your chance to kind of speculate upon what might have happened, given your knowledge of how dogs behave. So what other overt behaviors might we have seen in part 1 and part 2, behaviors that we could potentially observe? And then this is going to have to be pure speculation. What are some of the covert behaviors that might have been happening to these dogs? So what are some behaviors that these dogs might have been going through that only they could observe? So emotions, thoughts, things like that, that you couldn't directly observe, but might have been occurring. So let's speculate on some of those covert behaviors. Appetitive and aversive stimuli. So in experiment in part 1 and part 2, what were the appetitive stimuli? Things that dogs would approach. And then part 1 and part 2, what were the aversive stimuli? Things that dogs would try to avoid. In experiment in this, what were the temporally contiguous events in part 1 and part 2? So events that occurred close together in time. So there were clues to those events in my description of the study. And then also, what are the spatially contiguous events? For part 1, you're going to have to speculate on what is spatially contiguous because we don't know where the different events were located. However, for part 2, to help you with your spatially contiguous analysis, refer to that picture of the shuttle box. And again, what are the events that occur close together in space and which ones occur not so close together in space? And then for the contingencies, for these ones, what is the contingency between the shock and behavior for Group A, Group B, and Group C? So for the contingencies, remember, it's the probable occurrence of one event predicts the probable, occurrence of one event predicts the probable occurrence of another event. So pick the key event for part 1. What was the contingency between, so I'll give you a clue for this. What was the contingency between the panel press and the shock? So for some dogs, it didn't occur. For other dogs, it turned off. So for Group A, Group B, and Group C, what was the built-in rule? What was that contingency for the panel press and the shock? And then for part 2, what was the contingency for each group for the hurdle jump and the shock. So the event of the hurdle jump would cause the probable occurrence of what when it came to the shock. And then lastly, what is the functional relationship between the independent variable and the dependent variable? And this is for part 2 only. So the independent variable is going to be what happened to the dogs in part 1. How did that affect their learning, which is the dependent variable, in part 2? So try to come up with that functional relationship or describe that functional relationship. And I would encourage you to go through this exercise, download these slides so that you can see each of the questions, write it down, and then when you watch the next lecture, which is going to be the recorded lecture, I'll go through the answers for these, and then you can just kind of check them off. And this will help you identify whether you're misunderstanding any of these basic terms that we're going through, which again, these are the terms we're going to be using for the rest of the semester. So make sure you got these locked down because we're going to be talking about functional relationships, independent variables, contingencies, contiguity throughout this semester. All right, any final questions? All right, so that is it for today. So just a reminder, next class, do not show up here. I will not be here. Next class is going to be completely online. I'm going to put that link up where you can watch the lecture on the YouTube channel. I'm going to post that to Canvas. So please be sure to watch that lecture so that we can keep on track before you come to class on in a week from today. So you don't got to watch it live. It's not going to be live. I'm going to upload the recording whenever you want. So if you want to watch it during class time, feel free. If your plans fall through on Friday night, feel free, you know, whenever you want to take a look at it. But please make sure that you do that before our next class. Other than that, we are done for today.
Question.